Hi everyone, in this video we are going to have a look at this problem here, a bit different from what we've done in the past, but just a matter of unpacking it. So we've been given a function at f of x equal negative x squared plus 6x minus 5, and we're given the instruction to find the area bound by the curve and the x-axis. Bound by the curve and the x-axis. So let's start by looking at a solution whereby we look at graphing this equation first. Now, you should be able to see that this is a quadratic function, and you should be able to see that because the x squared term is negative, it's going to be a frowny face graph. Okay, and so it's just a matter of working out the critical points and going from there. So we've got a y-intercept. This is the solution. The y-intercept is when x is equal to 0. Therefore, y is equal to, and we can see it straight up, is 0, negative 5. And it's the x-intercepts that are really important if you think about it. Think about the context of the question. So if I let y equal to 0, I get 0 equals negative x squared plus 6x minus 5. Divide through by negative 1 or multiply through by negative 1, and you get 0 is equal to x squared minus 6x plus 5. And this gives me, using box method or cross method or whatever else, but two numbers that will multiply together to give me 5 that will add together to give me negative 6 is negative 5 and negative 1. So that'll be x minus 5 multiplied by x minus 1, and therefore x is equal to 5 or 1. So our points will be 0, 1. Oops, wrong way around, beg your pardon. So 1, 0 and 5, 0. They're the critical ones. I'm not going to worry about the turning point, only because I know what's going on here. I won't need it. So I'll zoom out so you can see all the things at once here. So if I'm drawing the graph now, here's my axes. That's my x-axis. There's my y-axis. I've got a y-intercept at negative 5. So if I go negative 5 here, I'm going to have an x-intercept at 5 and then an x-intercept at 1. So it's going to do that kind of thing. I just missed it slightly, didn't I? That's roughly what I want to get. Okay, so when we think about that graph then and look at what we've been asked to do, we've been told to find the area bound by the curve. So here's the curve, and it has been bound by the curve, the area. So here's all the area, but it has been bound by the curve and the x-axis. So I'm hoping that makes sense to you, that must therefore be this area here that I've highlighted. This must be the area bound by the curve. So it's going to be an integration problem like we've been doing, but we weren't explicitly given the left-hand side and the right-hand side of the area. But we are naturally constrained to x equals 1 and x equals 5 because of the condition that we were given in the question, which is that it is bound by the curve and the x-axis. So hopefully that makes sense. So go to slide 3 now and we'll continue the solution. So we know that the area, oops, I'll go back to black. We know that the area underneath the curve is given by considering the integral from the start point to the end point, so from 1 to 5 of the equation. So I think I'll just stick with negative x squared plus 6x minus 5, because it's the easiest integral to solve with respect to x. And so now I'm going to integrate that. So negative x squared is going to be negative 1/3 x cubed. 6x is going to be plus 6 times a half x squared. And I've got minus 5x. And it's going to be between 5 and 1. And if I just simplify that a little bit, negative 1/3 x cubed plus 3x squared minus 5x between 5 and 1. And now I'll substitute in and see how I go. So that will give me, just using the fundamental theorem of calculus, I'll substitute 5 in first. So I'm going to have negative a third, I'll use round brackets, I think, 5 cubed plus 3 times 5 squared minus 5 times 5. Okay, so that's that bit, minus a third 1 cubed plus 3 times 1 squared minus 5 times 1, like so. I'll leave those brackets in there so I remember that I'm subtracting a whole bunch of things, which will change those around. So on my calculator, which you won't be able to see on your screen here, but I'm just going 5 cubed is 125. So I've got negative 125 on 3, plus 5 squared is 25, times 3 is 75, minus 5 times 5, which is 25. And then I'm going to just figure this out in a single step if I can. Minus a third times 1 is negative a third. I'm subtracting negative a third, so that's plus 1/3. And then I've got 3 multiplied by 1 squared is 3, and I'm subtracting that, so it's minus 3. And then I've got minus 5 times 1 is minus 5. I'm subtracting minus 5, so I'm adding 5. So I end up with, let's have a look, I've got 75 minus 25 is 50, 50 minus 3 is 47, and 47 plus 5 is 52. So I've got 52, and I've also got minus 125 plus a third is minus 124 over 3. Okay, so then I just need to simplify that a little bit. So I'll just turn it into a mixed number, I think, and that would be equal to 52 minus, well, I'm just doing this in my head, imagining it's a paper 1 question, other than the fact I did 5 cubed on my calculator. So 3 goes into 12 4 times, no remainder. 3 goes into 4 once, with 1 remainder. So it's minus 41 and a third. And so I'm going to have 52 minus 41, which is equal to 11, and 11 minus the third is 10 and 2/3. So that's the exact answer to our question. The area is 10 and 2/3. So the critical thing here is, other than the sort of the mishmash of the numbers here, the critical thing is that when you've got an area bound by the x-axis, then you can effectively find the x-intercepts to give you the start and end point, knowing that the area is always the area under the curve, like so. It's really the area between, it's always the area between the curve and the x-axis. Okay, I'll leave it there for this video.